Today we're solving quadratics again, and we got some story problems and some plain Janers, but last time we solved with the quadratic formula. I want to tell you that the quadratic formula works every time. You can solve every quadratic equation with the quadratic formula. It works. But Algebra 2 asks us to do some factoring also. There's lots of factoring in college algebra and stuff like that. So we're just going to do these to practice factoring. So there's many types of factoring that I hope you've seen before. There's what I call easy factoring. I made up that name. That's when you have a quadratic, ax squared plus bx plus c equals 0. That's in standard form, and the a value is 1. The a value is 1. You can easy factor that. Why I call it easy factoring is because you don't have to do a lot of work to figure it out. But here's our problem. It says, suppose a ball has been thrown to the path of this. How long did it take for the ball to hit the ground? I cannot easy factor this. This is not easy factorable because the a value is not 1. The a value is -1. Can't do that. So what we're going to do is math magic. We really want to know when this ball hits the ground. Would you believe that's when the height is 0 in that case? You don't need to write this down, but I just want to show you the math magic that I'm about to do. But when I got 0 for my height in that case, because isn't that the height of the ground, right? The ground is at 0. What I could do is math magic called multiply both sides by -1. Would that be a legal move? Is that legal to do in mathematics, to multiply both sides by -1? What would 0 turn out to be when you multiply it by -1? 0. And what would happen to everybody over here if I took it times -1? Let's change their signs. So let's get started with the blue stuff. Everybody's sign changes right here when I multiply by -1. That's what your first move should be. All of these parabolas are going to open down because we're throwing a ball, right? And it's gravity bringing that thing down. So we're going to do math magic and switch all the signs in that case. So the a value is 1, and we could easy factor it. So to easy factor, your job is to find two numbers that multiply together to be -5, and at the same time add together to be -4. Let's focus on multiplying to be a negative. You got to think about what the two signs of the numbers are going to be that have to multiply together to be negative. You got three choices, either both positive, both negative, or one of them negative. What should be true about these signs? The faster you show me that you can factor, the faster I'll go through this also. So what should be true about these two signs? Should they both be positive, both be negative, or one be negative if they have to multiply together to be a -5? One of them's negative. So I need numbers that multiply together to be 5, but one of them had to be negative. I'm starting with this basic list. Would you believe there's like two combinations? Either the 1 could be negative or the 5 could be negative. Which one of these sets is what I call the bingo numbers, the numbers that multiply together to be -4? Top one or bottom one? So I like it if you write those two numbers down. You don't have to make this list that I'm putting off to the side, but I like it when you find the two numbers that you put them right here. And here's where the easy factoring comes into play. You don't have to do all of that crazy work that we call frowny face factoring. You just simply bring the 0 equals down, and you put your two sets of parentheses times each other with whatever letter they're dealing with. Most of the time it's x. And the two numbers that you just found, one of them was a +1, and the other one was a -5, right? They go in the parentheses with it. And we use what's called the zero product property. We got rid of all the squared stuff now. That's what makes factoring so nice, is now there's no more x squared. It's all x's to the first power. And you got two dudes times each other. You got a green dude, and you got a blue dude right here times each other, and they're supposed to multiply together to be 0. Well, one of these groups has to turn out to be 0 for that to be a true statement. So what value of x makes the green group 0 if x was how much? -1. Would you agree with that? If x was -1, wouldn't that turn out to be 0 right there? Or the other possibility is if the blue group turned out to be 0, and wouldn't 5 make that 0 in that case? This is the algebra of solving that. X could be -1 or 5. Since it was a story, though, and they asked how long did it take for the ball to hit the ground, we have to see if these answers make sense or don't make sense. Do both of them make sense, and we want to throw some of them away? Throw away the negative. That makes no sense. So we're going to say 5 seconds. It took 5 seconds for the ball to hit the ground. Again, I just made these problems up. So it's like, that's a pretty long time for someone to throw a ball, and it took 5 seconds. It's like, don't worry about if it makes the most sense or not. It's just about factoring is all I tried to do. I had to pick equations that factor real nice. So let's do that again. Here's a ball. It's been thrown at this path, but bro, we can't easy factor it because the a value is not 1. So we're going to change everybody's signs, but you got to have the 0 equals part. You know I'm picky. We got to have that 0 equals and then change everybody's sign. So the negative x squared became a positive, this became a negative, and that became a negative. That way I can get this a value to be 1 because that's the only time we can easy factor. Your job, find two numbers that multiply together to be negative 16 and add together to be negative 6. So we found our two numbers to be 2 and negative 8. Since this is an easy factorable situation, it's just going to be x plus 2 times x minus 8 equals 0 in that case. And to solve, we do the zero product property. X could equal, what value of x makes this 0, my friends? Negative 2. And what value of x makes this 0? 8. Story, how long did it take for the ball to hit the ground? Negative 2 doesn't make any sense for that story, so we're going to cross him out and put 8 seconds. You okay with that? That's easy factoring because the a value is 1. Just because we need probably a little bit more practice, here's a few more quadratic equations to do easy factoring. A value already is 1. We don't need to switch the signs. So our job is to find two numbers that multiply together to be a positive 21 and at the same time add together to be a negative 10. Let's talk about signs. If the two numbers have to multiply together to be positive, right, their signs have to be the same. They're either both positive numbers or both negative numbers. So it's not like one of them can be negative. That would be bad. What do you think? Should both numbers be positive to add together to be a negative 10, or should both numbers be negative to add together to be negative 10? Both negative. So find yourself two numbers that are both negative that multiply together to be 21 and add together to be negative 10. And that's negative 3 and negative 7, right? So this easy factors x minus shui times x minus 7, and then x could equal 3 or 7. We don't need to throw any of these away because it's not a story problem anymore. It's just an algebra problem, so we're solving for x. Why don't you do that to number 4? Easy factor. A value is 1. Please pause the video and get that done. We found negative 2 and positive 9, so factors like so. And then x could equal 2 or negative 9. Not throwing him away because it's not a story problem. One more, baby. One more. Get her done. Please pause the video. I solved it with the quadratic formula just to show you that it works every time. Quadratic formula takes a lot of work, though. It's the same amount of time. Like, you don't save any time doing the quadratic formula because you always have to do the exact same moves. It just so happened that the discriminant turned out to be a beautiful little number like 4, which is a perfect square. But I do think that it's a little bit faster, in my opinion, if you can find the two numbers that multiply together to be 24 and add together to be 10 and 4 and 6, and you just do this blue work. X plus 4 times x plus 6 equals 0. X equals negative 4 or negative 6. So if you're ever on a major test where you need to solve a quadratic, the quadratic formula works every time. Sometimes, though, it's just more time-consuming than just easy factoring, especially when the numbers are really, really tiny. You know, it's like, hey, but if you're not sure how to find those numbers, then the quadratic formula could be a good way to do it. You will have to do it by the way the instructions tell you to do it, though. If they say solve it by factoring, you got to solve it by factoring. That was the easy factoring. A was 1. Frowny face factoring. This is where it takes a little bit of work. But I've also made the number small enough to where it's not like a pain in the butt. But you can't easy factor this, dude, because the a value is totally not 1. And we can't do like math magic to turn him into a 1 by just changing all the signs. What I do want to do, though, since these thinking parabolas open down, is I do want to change all the signs because I like it when the a is positive. It makes more sense to math students if the a is positive. So let's roll like this. 2x squared minus 11x minus 12 equals 0. I think if the a value is negative, you should multiply all the signs by negative 1 to make him positive. it helps us factor it easier because then you don't have to start taking out negative GCFs and stuff like that. So we can take out a positive GCF. Why frowny face? A is not 1. Here's why I call it frowny face. I just made that name up. That's not what it's called. It's called factor by grouping is what it's really called. But I literally make this frowny face to multiply A times C and get negative 24 out of that. Negative 24 is what these multiply together to be. I got to find two numbers that multiply together to be negative 24 and add together to be negative 11. So since these multiply together to be a negative, my signs have to be different, right? One's negative. So 1 and 24, but that's not going to work if one of them was negative. 2 and 12, if one of those was negative, they're not multiplying together to be a negative 11. 3 and 8, if one of those was negative, that's not happening. 6 and 4. Did I get stuck here and paint myself into a corner and made up a bad problem? We cannot find the two numbers that multiply together to be this. So if you cannot do that, you would have to use the quadratic formula to solve this. But since I just made this worksheet up this year, we're going to say there's a typo on here, and instead of this being a plus 11x, we're going to call it to be a plus 10x. How does that sound? Plus 10x. So we can practice frowny face factoring. Now, can you find two numbers that multiply together to be a negative 24 and add together to be a plus 10x? So sorry to everyone out there in video land. We made a boo-boo. So two numbers that multiply together to be negative 24 and add together to be negative 10. Because remember, we changed the signs right there. Yeah, it's the 2 and the 12, and one of those is negative. So shouldn't it be the negative 12? Are you okay with that? So, hey, you caught me making a mistake right there, but we fixed it. We just changed one of the numbers. Now let's frowny face factor. Here's what that means. You don't, hold on. So here's our two numbers. You don't just get to go jumping straight into easy factor, and you have to do a lot of work. So we're going to split these three terms up into 4 terms. 2x squared, and then these two nuggets that we just found, we're going to put them next with an x with them. I'll tell you, it's so much easier if you put the negative one first. It does not matter what order you put these in, but since one of them is negative, we're going to put the negative one first and the positive one second, and then the minus 12 is still there. So these guys were the original beginnings and ends. All we did was split this negative 10x up into these two terms right here. Then you double group. So we'll group the first two, group the last two. And we'll take the GCF out of each group. So what's the GCF? Greatest common factor is what GCF stands for, between a 2 and a 12. 2, and then this has x's and this has x's in it, so can't we at least take out a factor of x in that case? So we can take out a 2x. What we'd be left with is an x, and then the minus comes down, and what's 12x divided by 2? 6. Please stop me if you have a question, but I took 2x out of that first group. Then on the next group, whatever sign this is, that's the sign of the GCF you have to take out. So since this is a positive, we're going to take out a positive also. Between the numbers, the 2 and the 12, can't a 2 come out of that situation. But you can't take an x out again because, like, this has, what the hell is going on? Because this has x's with it, but this one doesn't have x's with it in that case. You okay with that? So, all right, so we'll take a 2 out, and what we'll be left with is what? X minus 6 again. That has to happen. These two groups have to turn out to be the same thing both times in that case. So then we factor, we regroup. These two GCFs become a group of their own, 2x plus 2. And then the common group of x minus 6 comes down for the ride. And man, we use the zero product property. This one's pretty easy. What value of x makes this 0? If x was 6. And in this one, we do what's called the opposite of this guy over this guy. Like we're going to solve by doing opposite of this guy over this guy. Opposite of this is negative 2, right? Divided by this guy, wouldn't you get negative 1 in that case. Opposite of this guy over this guy in that case. And I'll totally admit that since I just made this up on the fly, I noticed right here that we messed up again. This has a GCF of 2 in it. That should have came out way up here. Doesn't 2 go into all of these terms in that case? That's why this turned out that these numbers still had a GCF of 2. So that's what I get for not doing the practice ahead of time. I made up a problem and it didn't work out very well. But the next one will definitely work out very well. Let's do it again. Frowny face factor to see where the ball hit the ground. So we're trying to find the zeros. We're going to change all the signs though. So everybody's sign changes. That way that first number can be positive. And then we'll multiply these two home slices together and get a negative 30. And I got to find two numbers that multiply together to be negative 30 and add together to be negative 13. I'll let you mess with that with a neighbor. I go through sequential order. I go 1 and 30, but one of them had to be negative. This one right here? I was just trying to find two numbers that multiplied together to be negative 30, so it was like negative 1 and 30. Yeah, it was just my list up there. That's cool. That's a good question. Okay, so double group, and take the GCF out of each group. Just go one group at a time. Let's work on this first group, and I look at the numbers first. I got a 3 and a 15. What number goes into, what's the biggest number that goes into both of those evenly? 3. And these both have x's with it, so you take out the smaller amount. Here's an x squared, here's an x to the first, so you always take that out. Then you just divide these nugs by 3x, and you'll get x minus 5. You could always check if you distributed this 3x again, you better get 3x squared minus 15x. The reason why I put the positive guy right here all the time is because that's the type of GCF I need to take out. I need to take out a positive GCF. Whatever sign this is, I got to take that GCF. So if I put the negative one there, I'd have to take out a negative GCF. We'll see that in a second. But between a 2 and a 10, isn't there a 2 that comes out of there? And then x minus 5 happens again. You're supposed to get this group twice. You just regroup after that. The two GCFs become a group of their own. And then the common group comes down for the ride. Now we can solve with the zero product property. And now's where opposite of this guy over that guy makes more sense. What value of x makes this 0? Opposite of this over that. So what do you think? Negative 2/3 or 5 in that case. Weird. Weird, weird, weird. Get you started on the next one. Just plain old frowny face factoring, so it's already equal to 0. I just want to do this one with you because of the goofy sign things that happen, right? I'm not saying you don't know how to do it already, but we'll multiply, and don't you get a 20 out of that situation? Find two numbers that multiply together to be 20, but add together to be negative 9. Think about their signs. If they should both be positive, both be negative, or one be negative. They have to multiply together to be 20. And then if you could check your two numbers with mine, and then we'll do the frowny face together. So all I really want is you to find the two numbers. Okay, so 0 equals 10x squared. What order to put these in? It doesn't matter. Even if you mix them around, we'll still get the same answer. Our work will be different, but we'll still get the same answer. But now, because this dude over here is negative, we're going to have to do some funky GCFing because we got to take out a negative GCF in that guy. So I'm going to double group. Everything's still the same, double group. But I'm going to sneak a little plus inside of this right here so it doesn't look like I'm multiplying those together. I'm not going to mark you wrong if you don't do that, but it just looks like if you don't have anything in there, they're being multiplied. Let's take the GCF out of the first group. And what's left is 5x minus 2. See, I got to get a 5x minus 2 back again for this to work out right. But it doesn't look like that's going to happen But because this is negative, we have to always take out a negative GCF. So we will do that. And then whatever number is common to both of these is what we'll take out also. Between a 5 and a 2, isn't that GCF just 1 in that case? But it's got to be negative because of taking this out. And then when you take out the negative GCF, you've got to divide all these homies by -1, so like their signs change. This negative 5x divided by -1 is 5x, and this positive 2 divided by -1 is -2, and that's how you end up getting the same group both times, because we factored out a negative. So then you regroup. And then you do the zero product property. Opposite of the second guy over the first guy. One more frowny face. I'll let you guys do it. Pause the video and gear down. Work together if you want to. Okay, so I hope you got her done. You should have found two numbers that multiplied together to be 24 and added together to be 10, and those happen to be 4 and 6. So then you write them as 4 terms. It doesn't matter if you had these two switched around. That's perfectly fine. We'll get the same answer by the time we're all done, but our work will be different. Double group right here. Take the GCF out of each group, and then these blue GCFs will then become a group of their own. I call it the regroup step. So regroup. 4x plus 3 becomes a group, and the common group comes down for a ride. Like I said, if you had these in a different order, you have a different common group, and you have different GCFs, but by the time we're said and done, you still have the same two groups by the end. Right? So then it's opposite of this guy over that guy, opposite of this guy over that guy. And I agree, we discussed it in class, that this probably takes a little longer than using the quadratic formula. So we're just doing it to practice those steps, because we'll need those steps in a few chapters anyway, so just a little bit of practice. Let me ask you this one, though, before we go to the last section. What if I gave you this quadratic equation? Would you use the quadratic formula on that one? There is a faster way. It's called the square root method, because you can square root both sides and get 5 or -5. And it's just like easy factoring. Sometimes that's faster than the quadratic formula. So it just depends. Sometimes there's better ways. Like this. I wouldn't want to use the quadratic formula on these either, because they are much, much easier to use the greatest common factor. Let's notice why these are different than all of the other ones, though. Does it have x squareds in it? Yes, it does. Does it have x's to the first in it? Yes, it does. But it doesn't have that constant term in it, like just that plain old number. So you could take a GCF out, and that'll work out pretty slick. So we want it to hit the ground again. So that means that the height, which is y, is going to be 0. And what we'll do is we're going to just take out the GCF, because doesn't each one of these terms totally have x's in them, right? They both have x's. So we can at least factor out some x's. Maybe some numbers also. Find the biggest number you can. Forget about signs for a second. The biggest number you can that goes into both 16 and 64. I'll let you guys what do you guys think? I try 16. I see a 16 goes into 64. Does 16 go into 64? So 16 is the biggest number that goes into both of those. Here's our super duper secret to make things work out a little easier. Isn't this 16 going to be negative again? Let's factor out not the 16, but a -16. And we can also factor out an x. Okie dokie with that. So we're just undistributing, like the greatest common factor, undistributing a -16x. Then what would be left would be your x right here, because if you did -16 divided by -16, you get 1, and x squared divided by x is x. Then this has got to turn into a freaking minus, though, right? Because you're doing 64 divided by -16, and won't that be 4 times in that case? If you wanted to change the signs of these first, like we did on all the other problems, that works too. You could change the signs, but I'm just factoring out a -16x. And now, watch how easy this is. Y'all know the answer to this one. What value of x makes this orange group 0? 4. But this one is so easy that it's hard. A lot of people, I go, what value of x makes this 0? They say 16 right away. And it's like, aren't they multiplying these numbers together, right? And 16 times negative 16 isn't 0 in this case. What value of x would make that 0? If it's just 0. It's just 0 because you're multiplying them together. So the answer to this question is x could equal 0 or 4. I want to go through that one more time. Remember, 0 makes this 0 because it's 0 times negative 16, right? Because they're multiplied. These are adding and subtracting. That's a whole different story. So they asked for this toy rocket to be shot off. How long did it take for the rocket to hit the ground? Well, guess what this 0 means, since we got that for a solution. It didn't take 0 seconds for the rocket to hit the ground. What do you think that means? That's where it started from. The toy rocket started on the ground. So it was originally on the ground, then it went up and came back down, and didn't it take 4 seconds for it to land in that case? So we're still going to throw the 0 away because that doesn't answer the question of how long did it take for the rocket to land, you know, because it started on the ground, then it landed, so we're going to do 4 seconds. Last one is a GCF also. Just want to make sure you know why, because you're going to have to recognize that on the test, is because there's no constant terms. Everybody's got x's with it, so you can just take a GCF out. Right? Everybody's got x's. This has got x's, this has got x's. You can also take some numbers out. So find the biggest number you can. If you want to change the signs first, fine. If you want to factor out a negative, fine. Whatever works for you. So 0 equals, what's the biggest number that goes into 16 and 24 evenly? 8. I'm going to factor it out as a negative, though. And there's also going to be an x with it, right? Because doesn't each one of these have an x? So I'm undistributing a negative 8. That would give me a 2x left in here. And it's got to be positive. And a minus 3 left right there. With me on that? To solve, x could equal, this will always be 0 because it's just stuff being multiplied together. And we're going to do opposite of this guy over that guy, or 3/2. But then we're going to answer the question. 0 needs to be thrown away. What would you rather say, 3/2 seconds or 1.5 seconds? So we'll change it back to the decimal to answer the question. It took 1.5 seconds. You could use the quadratic formula on this. It would just end up being kind of weird because the c value is 0. You'd have a lot of weird stuff happening on. So not bad. Just a little bit of factoring practice with some stories involved today. Oh, I guess we're not done. I thought we were done. We got to do these problems. Not bad. I thought we were done. Carl started his own business. Oh, Carl's Cutters. I hope you find enjoyment in all the creative names I came up with all these people's businesses. So, Carl's Cutters. Guess what Carl sells at Carl's Cutters? Lawnmowers. How creative. His profit equation has followed this path. I'll talk about where this comes from in a little bit. We're going to talk more about profit next chapter, but his profit function is a parabola that opens down, where x stands for the number of lawnmowers sold and produced, and y is his profit, how much he makes. You guys know that profit is like how much money people are making, right? Okay, good. What is the initial profit for Carl's company? Initial. Talked about it last time. Initial is which one? X-intercept, y-intercept, or vertex? It's the y-intercept. Can you tell by looking who the y-intercept is? Remember you let x equal 0? So what is the initial profit for Carl's company? This number. It's negative. Bro, can profit be negative? Can companies lose money? Is that possible? Yes. So we're going to say $28,800, but we won't call it negative. We're going to say a loss. Why would Carl initially be in negative land? What happened? He's got to buy all the materials to make the lawnmowers, or just buy the lawnmowers for somebody else and then resell them. You know what I mean? It's like he has to invest some money into like all of the things he's going to sell, right? You know, so he's got to spend some money before he can make some money. You with me on that? So he started at a loss. How many mowers must Carl produce and sell to maximize his profit? When they mention maximum, do we want to find the y-intercept, the vertex, or the x-intercept? Let's do the vertex. Is this bad boy in standard form or in vertex form? Standard. So I didn't give you much room to do it, so we'll just kind of do it right here. X equals opposite of B over 2 times A. Please find the x value of the vertex. Shouldn't be negative. If you did, it's just a little write-down error or a typing error. Remember, it's the opposite of b over 2 times a. So that happens. Someone in class got a negative. It's just because we've missed a sign here or something like that. It's no big deal, right? You know, but common sense will take over and go, Carl can't sell negative to 300 mowers or anything, right? Now, how do I find, we might as well just find the whole vertex while we're doing it, because they're going to ask us the next number if my pen would start working again. So 306 is the x value of the vertex. How do you find the y value of the vertex again? Sub it in, baby. Use parentheses. Use parentheses. So move this out of the way. Negative 4 times 306 in parentheses, quantity squared. Damn it, this calculator. So I got it all punched in parentheses, hit equals, and I heard whoa from the crowd. Whoa, this dude's selling lawnmowers. This is like his business that he wants to make, right? He's profiting in dollars. It is okay to expect a large amount right there. It's like, yeah, the maximum profit that old Carl could do is make $345,000 and 700, you know, all this stuff. So expect that when it comes to profiting. If you've never bought a lawnmower before, because I doubt many of you have bought a lawnmower before, but they ain't cheap. You know, just a push mower is $200 or $300. You know, get one of them riders, and you're talking in the thousands of dollars in that case. So we can now easily answer these questions. How many mowers must he produce? Is it the 306 or is it the big number? 306. And we'll put the label with it, mowers. And the maximum profit is $345,000. And the 744. I just kind of say it out loud. What I do want to talk about, though, before we talk about breaking even, is why the heck this makes like a parabola in the case. And I'm not an economics major by any means. You can go talk to Mr. Hibbs or whoever wants to tell you, but I know the gist of it, right? Let's say that Carl over here is making these lawnmowers, right? And have you guys, what if he just made, let's say, 2 million lawnmowers? Like, do you think he's going to make like a profit off of that, or would he probably have bought too much stuff and lose some money? What do you think? He'd bought way too much. Because it's called supply and demand, right? There's only so many people, wherever Carl's located, that need a lawnmower. You know what I'm saying? And I don't know if all of you remember, it depends on how old you are, but a few years ago, all of our computers had a stylus with it. You know, like the juniors and seniors probably remember this, that they had a stylus with it. And I know the freshman and sophomore never had that one, but had a nice stylus. But in that stylus, you needed a battery, a quadruple A. Not a single A, not a double A, not a triple A, but a quadruple A battery, right? And when that battery died, your stylus didn't work anymore. So here's what I did. I totally bought a bunch of batteries and sold them to kids for $1. You know, it's like if you needed a quadruple A, I would sell you one for $1. I bought 50 batteries, and it cost me $20. Right, $20. Could I have profited off of that situation? Yes or no? Because I sold them all for $1. Because if kids individually went to Walgreens to buy the batteries, they're like $2.50, you know, to buy the battery. But I was selling them for $1, so they're like, that's a heck of a deal. But I bought them for 50 and sold them for 20. How much could I have profited off of that situation? If I sell them all, right? How much could I have profited? $30, right? So because there was a supply, right? I had a supply, and there was a demand for them. It's like I ended up making a profit. What if I decided to buy, or first of all, why did I get them so cheap? How come I got them so cheap? I bought them in bulk, right? When you buy things in bulk, they get cheaper. So what would have happened if I would have bought, say, 5,000 batteries? Do you think I would have made money or lost money in that situation? I would have had to spend probably $2,000 to $3,000, you know, like buying those batteries in the first place. Could I have sold them all, you know? Probably not, because we got rid of those computers, and now no kids don't have the stylus anymore, and it's like I'd be sitting on all these extra batteries in that case. So this is what happens with Carl. It's like he can only make a maximum profit because of the supply and demand. Not everybody in the world needs to buy a friggin' lawnmower. You know, it's like he's only got a certain amount. So that's why all these profit equations turn out to be quadratic. I'm just going to give you a little sketch because he can start wherever. He starts in the hole, and then all of a sudden he could sell it. And then it gets to a point where he has bought too much stuff, and it's like his profit's going to start coming back down, coming back down, coming back down. So you got to do the math to figure out what's the right thing to do. Let's figure out the break-even points. We have had a hard time in college algebra figuring out what break-even means. Let's go back to my battery example. What does it mean if I broke even? Yes, ma'am. I didn't make any money, right? But I also didn't lose any money. So tell me about your profit. It was how much? If you didn't make any money and you didn't lose any, your profit was how much? It's 0 in that case. Isn't breaking even making 0 profit in that case? So which one of these is profit? Is it X or is it Y? It's Y. We're going to put 0 in for Y into this equation up here. 0 equals negative 4x squared plus 2448x minus 28,000. And now they don't tell you how to solve this quadratic. I will give you choices. First, let's talk about GCF. There is a GCF because all of these are even numbers, but it's probably not going to help us because these numbers are huge. You know, they're ridiculously big. Even if we took a GCF out, it doesn't make them much smaller. Would you like to try to frowny face factor this, or would you rather use the quadratic formula on this one? What do you think would be better for our brains? Quadratic formula makes way more sense. I don't have to waste any time finding two numbers that multiply together to be this and add together to be that, because the numbers are ridiculously huge. It's like you spend all day doing that. So let's use the quadratic formula. Why don't you pause the video and get it set up, right? Isn't it like 5,909,000? So don't even write that long number. Just put 2448 squared minus 4 times A times C all over 2 times A. You with me on that? Then I'm going to go find in the discriminant. We'll write that down. So I got this big old number for the discriminant, negative 2448 plus or minus square root of big boy 5531904 all over negative 8. So I'll go punching that in. Negative 2448 plus the square root. You can use the previous answer button if you want to, so you don't have to retype that number. Your previous answer button is right over your minus, so second answer. Hit equals and divide by negative 8. And I got 12 for one of those answers. You find the other one. Got to do the minus. 12 or something. Negative 2448 minus square root of big boy, hit equals, divide by negative 8. What are we coming up with? 600? Sound okay with that? They both came out positive. We'll see that why when we start sketching our graph. So we did all of this first to sketch our graph. Now let's go ahead and make our graph. That's what this says. Put us all on the graph. Let's label the axes. What's the X stand for? Number of lawnmowers. And doesn't Y stand for profit? So make it real nice in this situation. I'm going to go back and just kind of do it all over again. Number of lawnmowers. And this is profit over here. In dollar bills, y'all. And we're just going to take these 4 answers that we kind of have up here and make a sketch of it in this case. First, we're going to start with the y-intercept. Oh, my bad. We'll call it the initial profit. Isn't this the y-intercept in this case? It's negative, though, so we're going to go down here, put ourselves a dot of 0, negative 28,800. Carl and his little mower company here started down in negative land. Cool. Then I want to just kind of feel this out. I like these x-intercepts next. This is where he broke even. So one of them is really, really tiny, 12. That means after he sold 12 lawnmowers, he busted even again. You know, he started in the hole. He has to sell 12 lawnmowers. Now he's back to even. And then if he goes all the way over to 600 lawnmowers, it's going to break even again. So I'm going to put the 12-0 right about here. I'm going to put the 600 0 way over yonder. And then I'm going to go put his maximum pretty much right between those two. Like here's the two x-intercepts. I'm going to figure out like where right between there is. This is around the 306 mark, but I got to go up way up here and call that 306, comma 345744. Just making a rough sketch of that guy. Doesn't matter what order you put these in. I've just always kind of done that first so I can get it all balanced out because the vertex is pretty much right smack dab in the middle of that. And here's the question. Should I keep this thing going? If Carl like bought 600 lawnmowers, that was way too many, right? And he would have like spent too much money on the lawnmowers and would make no profit. Could he have bought more lawnmowers than that and actually went negative profit again in that case? What if he bought 1,000 lawnmowers? Wouldn't that put him even further in the hole? So keep this thing going down, right? With research, with market research, is what they do in real life, you could totally see, yeah, about 300 lawnmowers is probably going to be what you need to buy, Carl. You know, it's like that's going to be your best scenario for you based on market research in that scenario. If you buy more than that, you'll have some money, but you probably won't make as much as if you just only bought around the 306 mark in that case. Okie dokie? So that was Carl. One more, man. Should be a little faster. This is Yolanda. What's she selling? Yo-yo. Do you guys even know what a yo-yo is? Just out of curiosity. Thing on the string, you know? Not much of a demand for those things, right? So Yolanda's making yo-yos, though. It's called Yolo's Yo-Yos. Yes, sir. Profit. What do you think? $600 loss. That's the y-intercept. Finding the vertex for the maximum, so we'll do that. And negative 62 over negative 0.2. Just watch those decimals. Negative 62 divided by 0.2. Did you get 310? And then what is our y value once you get 310? 9. Give me just 4 numbers in a row. 9010. Is that what we're coming up with? Yes, no, maybe? Cool. All right, so her maximum, how many yo-yos should she sell? 310 yo-yos. And the maximum profit of $9,010. Not as much money as old Lawnmower Boy, because guess what? Yo-yos are cheap, and not very many people are buying them compared to lawnmowers. More people want to buy a lawnmower than they probably need a yo-yo. Let's find the break-even. Let's use the quadratic formula to do the break-even. Get her subbed in and check back with me. I got her all subbed in. Punch for my discriminant, I got 3604. I'm going to do the math for you guys. The negative 62 plus the square root of 604. That came out decimally. You guys get a decimal number also when you did that? It just means that the math wasn't so nice, but, you know, it's like, so she's got to sell, like, probably not 9 yo-yos, but 10 yo-yos to break even, you know? It's like you obviously aren't selling part of the yo-yo, but we'll say about 9.8. We'll do 2 decimals. I guess that's what we have been doing. So we'll do about 9.83. Or the other one, I'll let you guys punch it in. So when you get the nasty decimals, don't call this 10, don't call this like 610. You know, it's like I know that's kind of tempting, but we don't want to do that. We'll keep them goofy decimally in that case. But that's what she'd need. She'd need to sell 10 or 611 would put her into the hole in that case again. So we'll start making our graph. We'll put our label on here, number of yo-yos. Come on, pen. Don't fail me. We're almost done. Number of yo-yos and profit. And then we'll start $600 in the hole. So 0, negative 600. I will go put about 9.383, comma 0 with an approximate sign. That's a 3. Didn't look like a 3, but it's a 3. Pen's really freaking out. Make that look like a 3. And I'll go put 610 way over here. 610.17, comma 0. And then smack dabber in between those two, I'll go put my vertex of 310, 9,010. So that was good that this turned out decimally, just to show us, whoa, not everything's going to come out perfect. That means you couldn't have factored it if it comes out all decimally, and then freehand. And it can go below the old y-axis. The pen didn't make that worth a darn. Apologize to everyone watching, but please do a better job of sketching that. My pen just isn't working. So, hey, let me know if you have questions, and have a good one, guys.